We are about to derive formula used in such type of questions. The formula is 2 mu t cos r equal to n lambda. So let's derive it with help of a diagram. Let us say that a ray incides at an angle I. This is angle of refraction r. So by Snell's law and symmetry, you can say this is r, this is r, this is also r, this is r, this is I. Now let us mark these points as O, P, Q, R, and we should also draw perpendicular from R on ray PX. So perpendicular from R on PX would be say at Z. Now we need to find path difference between rays that is emerging from R, okay, and emerging from P. So here path difference is clearly delta X equal to PQ plus QR plus lambda by 2 mu minus PZ. Now you may ask why I wrote here lambda by 2 mu. So basically you know that this is denser medium and this is rarer medium, and when light ray is reflecting at point P, so here it will undergo phase change of pi and lambda corresponds to 2 pi. So lambda by 2 would correspond to phase difference of pi, and here we are looking at this all stuff happen in medium, okay. So in that particular medium lambda would be lambda by mu, so that is why we wrote it in such way, and this is of air, okay. Now we need to bring both of this in terms of medium or in terms of air. So I will bring this medium term in form of path difference in air. So if I want to write this as air, then simply multiply it with mu, okay. So here we would be having mu times PQ plus QR plus lambda by 2 mu. And what is PQ? You can see from geometry that cos R is equal to thickness divided by PQ. So thickness by PQ is cos R, and we can write PQ as thickness by cos R. And similarly QR is also thickness by cos R. So this will be 2 times thickness by cos R plus lambda by 2 mu and minus PZ. Now PZ can be expressed in terms of sin I or cos R. Let us see, this is angle I and this is 90 minus I. So PZ is just cos I times PR, sorry, sin I times PR. This is cos of 90 minus I. PR into cos of 90 minus I is PZ. So cos of 90 minus I is sin I. So we can write PZ as PR sin I. And further we can write PR as thickness, we can write this as tan R equal to PR divided by 2, this is by symmetry half of PR divided by thickness. So basically our PR comes out to be T by 2 into tan R. T by 2, sorry, 2T into tan R. 2T into tan R into sin I. This is our PZ. Okay. Now you know that mu sin R equal to 1 into sin I. So you can just replace this sin I with mu sin R. So this is our PZ. Now write PZ here. So PZ is 2T tan R sin R into mu. So this finally comes out to be 2 mu t by cos R plus lambda by 2 minus 2 mu t sin square R by cos R equal to delta x. Now here part difference should be n plus half lambda because it is destructive interference. They said that we shouldn't be able to see the light. So for destructive interference, this is formula for delta x. It depends n plus minus half lambda depending if n is natural or whole number, whatever you take. So here in my case n is belonging to whole numbers, that is n starts from 0. So this is my formula. Now lambda by 2, on taking it on left side we get n lambda equal to 2 mu t times 1 by cos r minus sin square r by cos r. So you know 1 minus sin square r is cos square r and cos square r by cos r is cos r. So here is our formula derived, n lambda equal to 2 mu t cos r.